of January 2023. And this is section A, question number 1. So here you can see that question number 1 is which of the following is a scalar quantity? And we know that the scalar quantities are those quantities which don't need direction for their description. So displacement is a vector quantity, so it needs direction. So it means that option A is not correct one. So moment of force. For moment of force, we also need direction because if this is the pivot point, clockwise or the anti-clockwise movement, so we need direction. So moment of force we cannot select. Power is, we know that power is energy over time. And energy is the scalar quantity, time is also the scalar quantity, both are scalar quantity. So it means that the power is a scalar quantity. In this case, the correct option is the power. And weight also, we know that weight of an object is always x down, and it has also direction, so it is also a vector quantity. So only the scalar quantity in this option is the power, as it is energy over time. Second question is that which of the following describe the gravitational field strength? Gravitational field strength actually is the force exerted by any planet on the unit mass. So force means the weight. So we have weight equals mg, or g equals weight over m, and weight is a force. So force over m. So gravitational field strength, the definition is force per unit mass or the weight per unit mass. So in this case, we have the correct option, weight per unit mass, because this is the proper definition of the gravitational field strength, force over mass. Third question is that an object of mass m is resting on the top of a spring. So this is the object of mass m. The spring is compressed further distance del x. So this is the compression, and also this is the height. The force removed and the spring returned to the original length. So this is the original length of the spring. So in this case, the question, when del x becomes 0, the object has a vertical speed v in the downward or in the upward direction. Which of the following quantity describes the energy transfer? So energy transfer. So when the force is applied on the spring is compressed, and when the spring is compressed, work is done, and the elastic potential energy is stored in it. And when the force is removed, the spring moves up and to certain height. So when it moves up to certain height, it means that it has gravitational potential energy. It gains some gravitational potential energy, as well as it is moving with some velocity v in the upward direction. So it gains also the kinetic energy. So it means that elastic potential energy is converted into gravitational potential energy and kinetic energy. So we can have elastic potential energy. We have half time f time del x, and this is mgh for the gravitational potential energy. And for kinetic energy, we have half mv square, and the starting speed is 0. So in this case, the correct option will be the B, because here the elastic potential energy, this is converted to kinetic energy and less potential energy. So this is the correct option. Now we have another question is that a student measure the time taken for the steel bar bearing to fall measured distance in the air. The student uses these measurements to determine the acceleration due to gravity. Which of the following conditions is needed to determine an accurate value for the acceleration due to gravity? And this is the steel ball. So when the steel ball, it means that it is very heavy than as compared to the air resistance or something, means that. So airflow around the ball bearing should be laminar. So if it is moving down, so its weight is very much high than the upthrust or the airflow. So if it is laminar, if it turbulent, has not means big, it make no big difference. And similarly, the time taken to achieve the terminal velocity. At terminal velocity, we know that acceleration is 0. So when acceleration is 0, but we need acceleration equal to the gravitational acceleration. So it means that this option is not correct. The ball bearing should begin to fall before the timer started. If the ball bearing means just dropped and after that we will start the timer, then u is not equal to 0. In this case here we will take the initial speed equal to 0. But in this case the initial speed will not be equal to 0. And when the initial speed is not equal to 0, so we cannot apply the equation v square equal to u square plus 2a or 2gh from here. So in this case, we can say the air resistance and upthrust should be negligible because since this is the metallic sphere and metallic sphere has very high weight as compared to their resistance and upthrust, and these air resistance and upthrust are very, very, very small as compared to weight. So we can neglect. So in this case, we can say that this option will be the correct option in this case.